Hey, turn the lights back on. Wow. Retro electro tech. When real audio ruled the world.
Hello everyone, this is Retro Ernest of Retro Electrotech. Here we have the Yamaha CR820 natural sound stereo receiver, of which I did a preliminary evaluation on recently. In fact, if you want to check that out, a video or so back, yeah, it's easy to find. So in that evaluation video, of course, I wanted to assess the primary complaint. Now, I mentioned that the customer, when he dropped this off, provided a note. In that note, he was saying that he was experiencing noise, intermittent behavior, even to the point where he said he lost both channels. I don't know if he lost both channels intermittently when he was messing with controls, or if the channels just went kaput and didn't spring back for him. I don't think the latter is the case, because I haven't experienced that at all since the evaluation video. So I'll get into that a little bit more in a moment. But initially, when I first powered this on with signal in it, and I wasn't rolling video footage at that time, I didn't start rolling footage until a couple minutes after, when I swung the camera around to the scope display and started going through controls and all that. And that's what's in the video. But when it first powered on with signal in it and the relay contacts engaged, both channels popped in. Okay, I had both channels, but they were severely distorted, really ugly. One channel was partially collapsed, and they were both a bit bouncy and all that jazz. When I started reaching in there and messing with the controls dry, in other words, I wasn't injecting contact cleaner and working them, I just worked a few dry, namely the input selector. Initially, the input selector was a bit fickle, but when I rotated that a couple times, that resolved itself. But there were, of course, other controls that were causing some problems, and I'll get into that in just a moment. But what I'm trying to say is that both channels sprung back to life, and they've remained that way ever since. They haven't gone away, or whatever the case. Now, on that note, after the preliminary evaluation video, I've been running this on the bench here with signal in it, of course, and under load, different volume levels, putting it through its paces, and the waveforms have remained solid. They've remained stable. I haven't lost them, okay? So that's a good sign, of course. So mostly the controls were dirty, and the evaluation video, if you look at the scope display as I'm going through the controls, that's pretty evident. What's going on with the controls. In fact, the loudness pot that rolled away over there that I have pulled out, the loudness pot was inducing a lot of noise, intermittent behavior. It was distorting the waveforms. There was even some phase shift there between the channels. But when I would work it a little bit, I'd get both channels to pop back in. So this is the worst culprit of them all. So now that's why I have it pulled from the board. I'm going to give this a little bit more TLC, and all these controls here are going to undergo a multi-pass, multi-flush cleaning, and I'll get into that in a little bit. I won't talk about it at this moment. I'll just get into it. So yeah, besides that, all the controls look pretty good. Noisy for the most part, some worse than others, and then the switches back in there, I'm going to get to those in a little bit as well, excuse me. And the relay here, other than tarnished contacts, it's looking good. I looked at it under some magnification here. I don't see any contacts that are badly pitted. So after I give them a cleaning and a light polishing, this relay will live on for a while. And I think that this is the bottleneck here for sure. Everything else seems to be working okay. And I'll get into all that once I get all the controls resolved and go into some post-service testing and whatnot. I know this unit is going to do okay. For how long, I don't know. I mean, this thing is almost 50 years old. The customer knows that, so that's all well and good. He just wants to use it as is. So that's pretty much what he told me. If I can get it to pass clean signal just by resolving any issues with the controls, then great. He just wants to use it like that. So that's where the bottleneck is. I can tell obviously that that's the case. Everything else in here looks pretty good. Everything seems to be original. It looks nice, fairly clean. I don't see any parts that are bulged, like electrolytics, leaking physically. Nothing looks heat stressed, discolored from heat, whatever the case. Nothing looks cracked. All the solder joints look pretty good. There's going to be a few that I touch up. I still need to check this board out as well, solder joints. All the traces look good from what I can see based on my initial inspection. Wiring looks good, all that stuff. So I don't feel that there's a train wreck going on in here to where I don't want to take this on. If it was really bad and it needed a lot of work, if there were hands in here that screwed things up, if there was just a lot of crap in here, like I said, a little train wreck going on, then I wouldn't even want to service the controls if there was a lot of other stuff that absolutely had to be done, then and there. So, yeah, but the customer knows otherwise that, it is what it is. It's an old unit. Something else could go wrong. If it does, he knows where to find me if he wants me to get into more work, partial restoration, full restoration. But other than that, I'm just going to leave that alone, and I want to get to the controls, get that wrapped up so I can get this thing home and the customer can enjoy it. I wouldn't be surprised if this thing goes on several more years, but I also wouldn't be surprised if something else crops up, of course, because, again, it's an old unit and just the nature of electronics, things happen sometimes, so nothing to get all panicky about. But other than that, let me go ahead and start the servicing of these controls, and I'll get a little bit more into the discussion thereof. Okay, so the first thing I'm going to start with is measuring a baseline on this problematic control here via this analog meter. All right, so I have it set to times 1K in ohms mode, of course, and I'm going to start by clipping on across the two ends of the pots here. I say pots because it has two halves to it, okay? So each half of this stereo pot. So clipping onto the ends, reading across the resistive tracks. And this is a 20K times 2, again times 2 because there's two halves. So we should be sitting right about where I'm pointing. That needle should be right around here. This is 20, okay? And remember, I'm set to times 1K. So let me go ahead and do just that, and I'm going to start with the front section of the pot here, reading across both halves. So let me do that, clip on, and okay, so that's reading right about 19K, so right about 5% tolerance, okay? So let me clip onto the rear half. Okay, so the rear is a bit lower there at right about 16K, so what's that, about 20%, right about there. So within about a 20% tolerance. So there is a difference between the two halves, obviously. So I'm going to clip across the wiper of the first half, the front half, and one end of the track there, and see how it behaves when I'm transitioning the potentiometer through its range of travel. Okay, so starting at 0 there, I have the pot turned all the way down. Now, I'm not going to be bringing it up in a real fluidly smooth manner because this is a detented or stepped pot. So, it's a clickety-click pot. So I'm just going to bring it up one step at a time. But it should still move slow. It shouldn't, drop, get jittery or drop back out or whatever. It should rise in smooth increments like it's doing right now, so far anyways. So let's see. And we should get up there to right about 19K in this case because, like I said, it's within about a 5% tolerance. Okay, so that's not looking bad, this half anyways. And let me transition back down one step at a time. Okay. Okay, good. So that's not looking too bad there. Let me just try it one more time. Bring it up, bring it up, bring it up, bring it up. One step at a time. And by the way, I can feel kind of a rough spot, physically, mechanically speaking, a rough spot within this pot when I'm transitioning about, I would say, halfway through or something like that. There's a spot that gets a little rough there. Okay, let me try the rear section here. Same thing. Okay, so I'm turned all the way down. Let me bring it up just one step at a time. Whoa, yeah, that just shot forward and then dropped back down on its own like that. It shouldn't be doing that. Let me try that again. Yeah, you see that? Whoa. Lord have mercy. Yeah, that's just jumping up and then dropping back down. It's kind of, yeah, look at that. And I'm not doing it. It's just getting jittery and all that. Yeah, see that? Of course you do. And it's shooting way up here, close to 50K, and then it drops back down to 16, where it kind of levels off there. Okay, so yeah, that's not good. So there's a problem with that rear half there. So what I'm going to do, just for kicks, is go ahead and clean it out multiple times and see if I can smooth things out. I don't know about that little rough spot in there. It's not real horrible, but it is a rough spot nonetheless. I'm going to see how that does once I get it all cleaned out and add a few drops of fader lube and see what that does. If that cleans things up so that it's working reliably and transitioning reliably and nice and smooth and what have you, and that rough spot kind of irons out a little bit, then like I said, I may end up using this pot because as I mentioned, the customer only wants to get into this so far. This level of service, I'm not going to be going in too deep. All right, so I'm trying to save the customer a little bit of money here, and that's okay. Like I said, in this situation, I don't mind doing that. But anyways, let me go ahead and move into cleaning this out and then retesting this control and see if I'm going to use it or if I'm going to end up getting something else. As I'm exercising the shaft back and forth, the wiper contacts in both halves of the potentiometers, I want to get them to obviously scrub and sort of carve out a clean path, if you will, between the wiper contact and the resistive track. Okay, so over and over and over again. And also too, in the process of that scrubbing action that's taking place, if there's some tarnish or oxidation buildup on the metal contact itself, I'm hoping to kind of wear that down and scrub that away somewhat with the aid of the contact cleaner. And remember, I'm not using a contact cleaner that has a lubricant in it. I'm just interested in the straight up contact cleaner by itself. I'm going to be adding the lubricant later as a matter of course. In this case, I'll be using some fader lube. And anyways, the moral of the story here too is when you don't have access to the controls, really good access, and you're just trying to sort of spray and pray, and you're using something like deoxit or some formulation, whatever, that has a lubricant in it or whatever the case, then you got to be careful because if you don't have good access to the openings of the controls where you can really isolate the insertion of the contact cleaner, the injection of the contact cleaner, and really isolate it down, then you run the risk of getting oily crap all over the board, which is a situation here. Now, you probably can't see the detail that I can see, but when I was pulling out the board, and I could see that it has an oily sheen all over it, including all of the capacitors and semiconductors, the transistors, and so forth. So I'm going to end up cleaning the board off after I'm all done doing what I'm doing. I'm going to clean the board, clean all of the components, get that oily residue off of everything, because you don't want to get that stuff all over. And I understand that the customer probably went in here and tried to resolve it with some deoxit or whatever, something that had, or a contact cleaner that had a lubricant in it. And in and of itself, that's not bad, but I like to control the, number one, the amount of lubrication that I'm putting in, so that I could be a little bit more effective with this type of a, you know, multi-pass, multi-flush cleaning. But initially I just want to loosen up what I can, any accumulation, you know, any buildup, perhaps old lubricant. I want to get it flushed out while I'm exercising, carving out that path that I was talking about, and then reintroduce lubricant. So like on each side of the track, via these openings here, I just want to go ahead and get my little tiny drop on each end of the opening or openings, and then work the shaft back and forth and distribute the lubrication. When I'm all done, once everything is done, I've done multiple passes and flush these controls out. Okay, so that's what I'm going to end up doing, and let me go ahead and start with, of course, the problem child here. So I'm just going to get in here with my hooked applicator, and that had a little recoil. It just popped right out, so let me hold that down. Comes out pretty darn fast. I'm trying to control the blast. Okay, so that's good. And then just the, you know, back and forth, back and forth, back and forth, back and forth, okay? So I'm going to do this for a bit. So I'll go ahead and pop on back when I get this done, and then I'll add a few drops of fader lube, work it, and then we'll try this again on the analog meter and see where things are sitting. Okay, so I'm done with my last pass on this problematic potentiometer. So when I was sitting there exercising the control, I did, I think, a total of 4 passes. Yeah, I just decided I'm not going to use this potentiometer. I am clipped onto the rear half, and I'm going to show you the result of that multi-flush cleaning, that it did resolve the problem. In fact, I'll just do that now. So you can see the first step, second step, third step, fourth step, fifth step, sixth step, seventh, eighth, ninth, 10th. Okay, and we're right at 16K. So I'll just let it sit there for a minute. So I decided to forget about using it because, yeah, there's still that little bit of a mechanical rough spot around the center of the pot when I'm bringing it up through its range. There's just something wrong mechanically there. Even though you can see it's working fine, that multi-flush resolved the problem as far as that intermittent nasty behavior that was going on. But still, that, you know, the mechanical rough spot that I'm talking about, and also to the fact that there is a tolerance difference between both halves. Okay, like I said, this half here is sitting at 16K, the front half at 19K. Even though I could technically use it and it would be all right, yeah, I'm just going to go ahead and order a replacement. All right, so I stepped away for a moment just to order the replacement pot. So what I'm going to do in the meantime, of course, is just move along and get the rest of these potentiometers serviced. Still have the balance and volume pot over there. Get the contacts squared away on this relay. I have all the switches in the front that I'm going to gain access to and service. And away we go. Let me inject my cleaner into each half of each potentiometer. Let me get a little more in that one there. Okay. And let me prop up this end of the board for no other reason than being able to reach underneath and rotate the knobs. So I'm going to work my way from, you know, back to front, front to back, just back and forth, in other words. Exercise these controls again to carve out that clean path between the wiper contact or contacts and the resistive track. You know, loosen up accumulation and any old factory lubricant or previous applications of, you know, like deoxit or other such cleaners with lubricant in them, etc. Okay. And while I'm doing this, I'm going to provide a little information that might prove useful to some, not so much to others. So you be the judge if you want to skip on past at any point. Well, easy to do, right? So, first of all, the way I have the board positioned right now, I'm not too worried about the drainage and all that getting on the board, because remember I had mentioned that it looks like perhaps the customer, maybe somebody else, I don't know for sure, was trying to spray out the controls, doing that kind of spray and pray method. And I don't think that they got the boards out and got everything positioned for better access. But where I'm going with that is, and I mentioned this earlier, that there's an oily substance all over the board and all over the components, transistors, caps, and all that. So I'm going to be cleaning off the board anyways. Okay, I'm going to be using some 99.9% anhydrous alcohol. In other words, it obviously has a very low water content, so it dries fast. I'm going to be spraying that onto the board using a brush and just brushing everything off, getting all those components cleaned off, get that oily residue off of everything, in other words. And there you go. So I'm not too worried about drainage right now. And normally, yes, you will, especially controls that are really nasty and gunky and all that, you'll get a lot of drainage and ugly drainage, and even the old factory lubricant and whatnot. I'm going to go into that in a minute. That will drain onto the board, and you don't want that normally, but in this case, since I'm cleaning it off, that's why I'm bringing that out. Okay, so on that topic though, before I move further into things, and let me just do a few good passes here. On that topic, I keep a lot of cotton balls in the shop. And the reason why is because, and I have some over here just for demonstration, obviously I'm not going to use it right now, but you can pull it apart, shape it, whatever, do what you're going to do. And in this case where the board is laying flat, now a lot of times you see where I have the units positioned differently, the boards are kind of hanging in such a way that there's good drainage there, and I have some rags underneath, and I'm not too worried about it. And usually I'll go end up cleaning the boards off anyways, even after that. But when you have a board laying flat and you want to mask things off because you don't want to get the board dirty, you don't want the runoff or overspray to get all over everything. Yeah, cotton is really good because you could just, you got to be careful. Don't damage any of the components on the board, but you can use like a pick and push it down into position where you need it, okay? And just be careful not to damage components. You can push it down in there like so, continue on and do the same, with the other controls, get some masking in there. And the cotton is good because it's pretty dense in that it'll absorb a lot of that contact cleaner that's flowing out from underneath. It'll absorb it. If there's any overspray, it'll get in there and catch it and all that stuff. So there you go. But I'm not going to use it right now. So for those of you who like to do really neat work, for some people this might be overkill and all that, but for those of you that want to do really neat work, and that's just one way you can do it. More than one way to skin a cat. But I thought I would bring that up because all you have to do is just tuck that cotton in, and you'll have a nice barrier there to absorb the runoff and catch a bit of overspray is what I'm trying to say. So yeah, I'll continue forward while I do what I need to do here. So let me talk about this method a little bit, actually. The multi-pass, multi-flush method. Not so much how to do it because I already touched on that, and that's pretty elementary. But the objective to being successful with it is putting in the time, actually doing the work. And it does take time, but not as much time as some alternative methods that I'm going to just breeze over. And I actually kind of touched on them a little bit as well. And some of that is going to be for the purpose of just explaining that a little bit for those that are getting into doing this kind of work and how some of this information might help you out. So yeah, it's a very simple method, but you just got to put in the time, be thorough, go back and forth, do what you got to do there. And this method will work very well in clearing up problematic controls. It will last a long time, again, if you're thorough with it. And after flushing it out multiple times, when things dry out, like I said, you add your lubricant / protectant, whatever, and you do it very sparingly because you don't want to create a sludge factory inside. And I've mentioned that before. I mentioned a lot of this before because, again, this is all routine stuff. This is all part of servicing vintage gear, old gear that needs it at this point especially. But I'm going to point out one disadvantage, and it's not really a big deal. Most customers don't mind the fact that, yeah, when you're spraying these out, that contact cleaner is going to get wicked up into the bearing housing that the shafts extend through, and it's going to loosen up the controls. In this case, it's not too big of a deal because these are detented, okay? So if you're dealing with detented pots, stepped pots, and all that, loosening up the shaft isn't going to make much of a difference, okay? But on controls that are, they rotate smoothly, the shafts rotate smoothly through the range of the pot and are damped, they have that nice cushiony, buttery feel. Well, it's going to loosen them up. But again, the disadvantage is, very minimal in comparison to the advantage of restoring proper function to the control, which is the main objective, right? Right. And, working out the kinks, getting all the ugliness, the noise, the intermittent behavior and all that out. And, doing a good thorough job where it lasts a long time and, reintroducing your lubricant, all that stuff that I just explained. The benefits outweigh the fact that you're going to have a looser control. But the reason why it's not a big issue, especially if the customer doesn't mind, and most don't, is that it doesn't get so loose where it's going to be flopping around and you're not going to be able to set it. It's not going to hold its position. It's going to drift off of its position. That doesn't happen. I've never had that happen. And the control might loosen up, but once you set it, it stays there. It's not going to drift all around. So that's why this method is not a problem. If that was an issue where the control is just going to flop around, it's not going to hold its position where you set it, well, this would not be a good method, but it works just fine. Spraying out controls with solvent, contact cleaner, and all that, adding a little bit of lubricant, has been used in industry for decades. Okay, it's not something that I'm making up. So that's why I'm bringing this out. So there's that little disadvantage. And maybe the next very minor disadvantage in comparison to the grand scheme of things is that, yeah, you're not going to typically get the level of cleaning that you would get if you disassemble the control, get in there, and literally with a swab, you're cleaning in this case of potentiometers, you're cleaning the resistive tracks, with the appropriate cleaner, whether you're using like alcohol or a little dip of contact cleaner, really going in there until you're not getting any sort of discoloration or dirt off of the tracks anymore. You're literally polishing the metal contacts, getting them nice and shiny, really doing a thorough job, and then reintroducing a smear of damping grease into the bearing housing there that the shaft passes through, and you're able to restore that buttery function, that damped feel to it. Yes, that is a superior method over the multi-pass, multi-flush cleaning, but that's going to get into also bigger money, of course. It obviously comes down to the amount of time you're investing in that. Now, some controls, as I pointed out, are not of the quote-unquote disassemblable variety in that, yes, technically they can be disassembled, but unlike some multi-ganged pots, multi-gang meaning they have more than one section, like stereo pots have two halves and all that, multi-gang pots, some of them are actually made to open up, and that's still going to be more time consuming than what I'm doing here, especially if you're working on multiples of those. Well then, yeah, but they're still made to be opened up. You can get in there, clean them, re-damp the bearing housings, all that stuff. You're going to be able to do a deeper cleaning, but still, control condition is going to dictate the responsiveness to this multi-pass, multi-flush cleaning. So it's a good method if you do it right, if you take the time and you're thorough about it, and you do multiple passes, multiple flushes, and then add your protectant, lubricant, whatever after, then it does a good job. But the superior method is definitely disassembling controls. But like I said, with some controls, like this one here where I talked about, you know, having to grind off the rear section of the shaft, grind it down a bit because it's peened against the disc here. And then, you know, pulling that off, and sometimes there's clips, you know, an internal clip or so that add to the obstruction. You got to, you know, finagle that, work around that till you can pull these apart, separate both halves. And then in the end, don't forget, it's got to be reassembled. You're only halfway through when you get it opened up and cleaned out and contacts buffed out, polished and all that. But then getting it back together, you got to clamp your shaft in a vise, for example. Do a little bit of light machining, a drill press with a little micro bit, drill down the center of the shaft there, just so, a little hole there. And then use a little micro tap to thread the hole, a little machine screw, you know, washer, all that stuff to try to get this thing back together and whatnot. So that takes quite a bit of time, especially if you multiply that fact by numerous potentiometers, all of the switches that you might be pulling out if you're doing that level of restoration, that level of restorative work. I even had one guy recently, he was very disrespectful, and he was saying, you know, why are you spraying that junk in those controls? And any self-respecting technician is not going to do that. He's going to pull out all the switches, disassemble them all, you know, all that stuff that I just explained. In my country, we don't do it that way. Now, this is a guy that he owns a lot of hi-fi equipment, and I saw that on his channel because he has a channel, you know, he's in another country. He has some nice hi-fi equipment, but he claims that the techs in his country, they don't use chemicals, number one, which I know is BS in cleaning controls, contacts, and all that stuff, whether you're pulling them apart or not. And also too that they remove every single pot, every single switch, every single deck switch, you know, wafer switch, all that, pull them all out and do that. And I know that there's restoration jobs where that is done. I've done them, I still do them, and I will continue to do them, but on a case-by-case basis, and I will only take so many at a time. And those that I'm doing that type of work for have to understand that those are going to be sitting in the queue for a while, because I have to focus on work I could get in and out quick. So I'm doing those other jobs, those big top tier level 1 restorations. I say that kind of jokingly. Those are going to be done in phases, and those are going to be sitting in the queue for a while. As it is, I have long waiting lists. There's no getting around it because, again, high demand, full shelves. I'm a high volume shop in a time where, you know, it's just hard to find good help, period. That goes without saying. And that's true in just about every occupation, trade, profession, whatever. And people's work ethics and all that. It's just hard to find people. So I'm having to work solo most of the time. But that's why you got to be careful. You can't constipate your workflow and end up going broke, and you can't keep the lights on and all that. So you got to choose wisely, pick your battles when it comes to that. And I'm saying all this because some of you that follow this, who are getting into this, who are maybe even making a little bit of money on the side, or you're starting to build a customer base, you know, you're doing some pretty good work, but you're just getting into it. Be very careful what you take on, and especially if you don't have competent staff, okay, competent help to get it done. Otherwise, you're going to find yourself really stressed out, and yeah, it's not a good situation. But anyways, that claim that was made, I'm sure that in his country there are techs that are doing that, but they probably have the help, they probably have the staff, and they're probably even only taking on so much of that type of work. And also too, let's not forget the customer. The customer is the one who decides what they're going to pay. Some customers don't want that level of restoration where you're pulling out every single control and taking them all apart and cleaning them out, in addition to all the other restorative work within the equipment that you're doing. When you're doing that, what's sometimes referred to actually as a museum level restoration, when you're doing that type of work, a customer is going to be paying thousands of dollars for that type of a restoration, especially depending on the complexity of the piece of equipment, the accessibility to everything, how many boards involved, the population count, all that stuff. That all factors in, obviously, and you multiply that by, you know, doing, you know, pulling apart controls, taking them all apart, disassembling them, blah, 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 cleaning them, and then having to maybe even do some light machining to get them back together if they're not the type of controls that could be put together easy. In other words, they're not made to be disassembled. You multiply that across the spectrum, yeah, that's a lot of time. That's a lot of time, especially for one tech to be able to take on a high volume amount of work and pay the bills, make a living off of that like I do. So I will take on those type of jobs, but I will pick and choose those type of jobs, and the customers pay up for them. But there's those customers that want that. They want to pay up for that type of work. Okay, so that's okay. This is a perfectly good method, and it works very well, as I already explained, and it's very thorough, especially the way I'm accessing all the controls and taking my time and really going through and doing it. It's a good alternative that's not going to cost the customer as much, even though, yeah, it still takes some time to do and go through all the controls. And after this, I'm going to have to gain access into the switches. I've talked about that before, where I carefully establish a little access hole. I've explained that method, and no, that doesn't hurt the control. You have to know what you're doing there, and I inject cleaner in there and really work those switches over and over and over again. Very good method. Again, I reserve removing controls and opening them up to controls that don't respond well to the flush method of cleaning that I'm talking about. And on that note, again, that depends on the condition of the control and whatnot. But like I said, once I assess everything after cleaning, if there's still some controls that are a bit buggy, one or two controls, then yeah, I'll remove them. I'll give them a little bit more attention. I'll open them up, especially if they can be opened up fairly straightforward. Or if it's a control that's difficult to source and I can't just replace it, I'll opt to replace it first, definitely, and save the customer a little bit of money, save me some time, and just get it done with either an identical control or a good aftermarket replacement that will do the job, that meets all the specs, parameters that I need, and so forth. Not going to go into that, but yeah, I'll just replace it. But if I have to get into it, and even if I have to do a little light machining, I let the customer know what he's up against, the amount of time, that there's always that possibility that the control can even end up damaged despite my best effort, especially depending on the design of the control and all that. Because even controls that you're pulling apart and grinding down the peened area of the shaft, pulling them all apart, you have to do a little bit of light machining. They are not all made equal. They are not exactly the same in trying to get the halves separated and whatnot. Make no mistake about it. So it's not a one-size-fits-all endeavor when it comes to this type of work and control servicing, and you got to be aware of that to the prospective customer, and definitely to aspiring technicians or even active technicians who are having a hard time with balancing all this out and sometimes feel bad about not taking in all of the work. And you get all these higher dollar customers that have the money to spend, higher dollar customers and clientele. That's great. But if you have a lot of demand and they want you to do that level of restoration on every single thing you're taking in, yeah, you're gonna have a really tough time keeping up with things, and it's gonna really constipate your workflow, and that's not a good thing in the end. So a little bit of self-care, a little bit of advice, and choosing wisely so that you can do things a lot more effectively. Hey, look, this is my father's legacy, okay? But I'm doing it on my own nowadays. I'm moving forward, running the business the way that I feel I need to run it nowadays. I have no help. I have to sort of pivot and readjust in areas. Now that I'm working alone, the demand is super high. There's not as many shops as there used to be. We're on the endangered list. A lot of us are getting older. A lot of techs are aging out, closing up their shops, this and that. So being that there's that big imbalance going on, there's still a lot of demand out there. There's all this resurgence. People are realizing that this equipment is just really great. They want to get back into the analog. They're resurrecting all their old equipment. Even the younger generation is kind of jumping in, and demand is super high. Musicians that want to keep their vintage synthesizers going, their guitar amps and all that stuff. The demand is extremely high, but the workers are few. So guys like us get really swamped. And we have to be very careful when it comes to self-care and not to burn out and end up dropping dead at the bench. So very important stuff I actually brought out. Even though it was long-winded, That's really important stuff, especially for guys and gals that are getting into this. Keep that in mind. Okay, so I wanted better access to the volume and balance controls here. So oops. Recoil. All right. Okay, so this volume and balance pod here I'm going to use to show you where I apply a lubricant, in this case a fader lube, when the control is closed. Okay, so down in these ports here where I was shooting contact cleaner, each one of these terminals here on the ends represent the ends of the resistive track that runs in a semicircle. Okay, so up in there a little further is where these terminals connect up with the ends of the resistive tracks. So keep your eye on this side over here and this side over here, these two halves, and you should be able to see, it might be a little difficult, but you see the wiper contacts there, and I'm rotating the pot. And if I turn it around the other way, on the other side over here, the other sides, you might be able to see the wipers again. I don't know, they're a little harder to see on that side, but neither here nor there. They rotate. Okay, there they are again on this side. They rotate all the way around, you know, back and forth as you rotate the shaft, of course. So I'm just going to back off the contacts here, just kind of back them off out of the way. And I'm going to stick the applicator of the lubricant. Matter of fact, let me do that. Okay, so I'm going to try to do this without my hand getting in the way. Normally I would go in at a, you know, just straight on and in. But the problem is that the autofocus will focus on the bottle, and then the openings here will get all blurry. So I'm just going to kind of show you at an angle that I'm going to go in just enough to reach the beginning of where the terminal here connects up with the resistive track, which isn't very far in at all. It's just pretty much right there. But I go in a little bit past, and I don't want to push my way in. I don't want to push my way in too much, okay? Because I don't want to run the risk of bumping against the contacts, the wiper contacts, bending them, causing damage or whatever. And it's not necessary to go far in. Okay, so that's what I'm going to do. And then, of course, I have to squeeze the bottle a little bit to get a drop of this fader lube out there, out of here. But anyways, let me set this right here, because I want to show you how much I'm going to put in. And just for demonstration's sake, let me actually show you how much. I'm just going to drop it here on this terminal, okay? But just note, for those of you who've never done this before, just note how much I'm putting in. You see that drop? Just like that. That's it. That's all I want to put in. And once I put a drop like that onto each side of the track and rotate the wiper around, it's going to distribute that around, you know, the track. And when everything's said and done, after running it for a while, it'll turn out to be, you know, a fairly light sheen or film of that fader lube on the track. Because remember, like I said, I don't want to create a sludge factory and, you know, just squeeze a whole bunch of that stuff in there. So that's what I'm going to do. That's all you need. And, you know, this stuff is expensive anyways, as a lot of you know. This stuff is expensive. There's other stuff you can use too, but I'm not going to get into that. This isn't about all the different alternatives and all that, not this video. But anyways, yeah, I use Fader Lube interchangeably with some other things, and it's good stuff. And yeah, it'll help to, of course, lubricate and protect. So all's good. So that's pretty much it. No rocket science there, but sometimes it helps when you see for yourself, you know, visually what a person is doing, and it'll give you a better idea. Okay, so all the potentiometers are completed, relubricated. Of course, I'm waiting for the loudness replacement. So what's next is all these push button switches. You can see them all, yeah, tucked back in there, and then these right here. So you might be able to tell that I've already established access ports up in here. Let me go ahead and zoom in on one. Okay, so you can see the access port in there. All right. Okay, so I'm going to finish off this last switch on camera. I'm going to gain access into it by coring an access hole right in this area here. Okay, and I'll get into that in just a moment as to why this area. Now, I've covered this topic before, but as I often do, I repeat these little video segments for some of the newer people that choose to utilize this method. If you're not confident in doing it, or you feel a little bit queasy or whatever about gaining an access hole into the switch, and for those of you who feel it may not even be necessary, then simply don't do it. If you opt to desolder the switch and try your hand at disassembling it, which these switches can be disassembled, you just have to finagle around with them and pop this area open, pull out the carrier via this plunger, you know, pull the carrier out and all that stuff. Not all of them are exactly the same, but for the most part, you know, you can gain access into these. You just got to be very, very careful that you don't damage the little body of the switch or crack something or whatever the case. It's not rocket science getting in, but at the same time, if you're not confident in doing that, disassembling a control, same thing, you got to be careful. I've disassembled these as well, many of them, and when I'm doing that, when I'm exercising that, you know, level of service, when I'm in it to win it, and I'm being paid for that, I'm not being paid for that here, and as a result of not being paid for that, that's fine, it's okay. There's other ways to do it. There's more than one way to skin a cat to gain access, and what I like to do is I feel better about flooding the control, really filling up the cavity with a copious amount of cleaner while I'm, you know, exercising the plunger over and over and over again, allowing the internal contacts to scrub against each other, to wear down, tarnish buildup, oxidation, and, you know, whatever else. So I feel better about that when I'm flooding the control with copious amounts of cleaner and working that, okay? Now, some of these switches that look similar to this are open in the back, so obviously you don't have to worry about how you're going to get cleaner in there, at least a good volume of it. Some people dribble contact cleaner in through the front, yeah, and you can do that. You can even blast a little bit through this. You know, this switch happens to have this white area here with the slit and all that stuff. Well, you know, you can dribble a little bit. In fact, I can see in there a little bit. You can kind of see the plunger moving around. There's not a lot of room between the plunger and the body though. So whatever you kind of dribble down in there, and even through here, you can kind of dribble contact cleaner depending on how you have the switch positioned. You want to let gravity work in your favor. Right now I have this, you know, upside down, so I wouldn't try to dribble contact cleaner up anyways. Gravity's not working in my favor. But if you have it flipped over the other way, you can dribble contact cleaner while you're working the plunger, and it will permeate, it will get in there. It's just not the way that I like it. Again, I want to get a little bit of pressure in there. I want to shoot it, flood it in there, work the control, flood it in there, copious amounts, like I said. Again, I'm re-emphasizing that. And I feel confident with the method of coring an access hole into it. Again, and I'm going to repeat it a few times, if you're not feeling good about that, simply don't do it. Find another method, you know, any of the ones that I talked about, disassembly, maybe try and access through the front, whatever the case. So why did I point out this area here? Well, when the plunger is disengaged like it is now, see right here, it's engaged, it's disengaged. When it's disengaged, there's a void up in this area where the contact carrier is not present. If I push it inward and engage it, that contact carrier, shuttle, whatever, raises up and it's probably situated in here somewhere, thereabouts. So disengage, there's a nice little void here. Now, what some may wonder about, and I cover this in all the videos where I talk about this method, and I didn't invent this method. I'm not taking credit for that, of course. Techs have gained access into a lot of different types of sealed switches that they're comfortable accessing because they understand what's going on internally, where you might find some voids, and able to core a little dainty, gingerly little access hole into the body, not disturb anything. Inject your contact cleaner, whatever, work it, and clear up an otherwise very dirty intermittent control without trying to get into it and tear it apart and all that stuff, especially if the budget isn't there, the customer's not paying for that. It's a risky control to try to take apart, whatever the case. There's different reasons, so I'm not going to get into everything. But this isn't something that I invented. It's been done a lot by many techs, and it's not a big deal. If it's done right, it's a very good method that I've had great success with in clearing up nasty, noisy, intermittent controls. So I'm going to core right about here, and I'm going to do so with a little, you can either use a pen vise, I'm going to use an Archimedes drill. I'm not using a power drill, I'm just using a little Archimedes drill, okay? And let me go ahead and get started, and I'm going to talk about it as I'm going through. I'm going to be pausing a lot more than I would normally do because I'm going to explain some things along the way. So you see the Archimedes drill, it's one of those pump kind of drills. And let me just kind of demonstrate what I'm talking about. Just let me see if you can see that little, you see how it's, I don't want to zoom out or anything, but yeah, this little worm gear here just kind of, rotates and plunges this bit in and out and all that. You get the point. But anyways, okay, so right about here, and you'll see, my hand's not in the way. You'll see it in action. You see what it's doing? All right. So I'm just going to start working my way through. And I'm going to move a little faster because, again, I'm very confident doing this. You see how they, you see how that residue there is accumulating around the bit, around the hole? Well, that's what I'm clearing off. Okay, I'll blow it away. So I'm cleaning out the hole as I move through. All right. Because I don't want a bunch of shavings or that powder residue, that plastic or phenolic, whatever you're drilling through. You don't want that accumulating. And right before I'm ready to pop through, I'm going to meet up with some resistance. All right. It's not just going to pop through. Like right now, I'm starting to meet up with resistance right about there. So I'm going to pull out. I'm going to clear that hole once again. I'm going to brush off the tip of the bit because there's a little powder on the end of it. I'm going to just brush that off. Okay, so when I pop through, I'm just going to go through real slow, and I'm not going to pump my way through. I'm going to hold the chuck with my fingers and just turn it with my fingers really slow, okay? And just pop through very slowly. And once I pop through, okay, you see what I'm doing? When I pop through, when I rotate through, I'm going to rotate in the opposite direction counterclockwise, and I'm going to extract the bit. Okay, I'm just going to extract the bit carefully so that if there's any little little accumulations of powder residue on the end of the bit, or maybe even a little tiny micro shaving clinging on, I'm just kind of pulling that out with the bit. Now, is there going to be maybe a tiny bit of powder residue, maybe even a little micro shaving that falls inside the switch? Yeah, a good possibility, probably so, just by the very nature of what I'm doing. But I've never, and I repeat, never have had any type of residue or whatever the case, however minuscule and tiny, I've never had anything cause any type of rough, gritty operation of the plunger, the contact carrier moving around in the switch body. Never have had that happen. And remember also too, as I start flooding cleaner in there and really getting a good blast of cleaner, I'm also scooting any type of crap out of the way. It's probably working its way out through some of the tiny little cracks. Keep in mind that the inside of these switches, they don't have little tiny micro tolerances, okay? They're not so tight internally that a little tiny bit of powder residue or a little micro shaving is going to bog down the whole switch assembly and cause it to seize up, or it's going to start getting all rough and gritty or anything like that. If that was the case, if I would have encountered that kind of stuff, I would have abandoned it and said, hey, you know what, I don't want to take that chance. But I've never run into that. It's a very sound method when it's done right. So now let me go ahead and let me go the rest of the way through. My hand might be in the way for this part because obviously I have to twist the chuck with my fingers and just barely pop through. Okay, I'm through right now. I felt it go through. Okay, so you have a nice clean hole now. You can see that nice clean hole, at least I think so. Yeah, looking at the back of the camera. But you can see the contact carrier. You see it? That's why you don't want to have it engaged, because it's sitting right there at the edge of that hole. Okay, good. Flooding that control nice. There we go. All right. Now I'm just going to reach under so I can access the plunger. And you can even see the plunger moving past that access hole, okay? And when I'm all done flooding these controls and working them over and over and over again and finish off what I need to do, I'm not going to leave those holes open. I'm going to put a little round, just a little tiny round sticker over the holes to seal them up. All right, that's how I'm going to conclude with everything. So it's a very sound method. I get a lot of cleaner in there and flood the body of the switch. That's the objective. Let those internal contacts scrub against each other with the aid of that cleaner, and hopefully wear down, tarnish, oxidation, get it all cleaned out and reestablish good proper function, good stable function, and not be dealing with a noisy intermittent switch. And I've had great success, and it lasts a long time, okay? Alright, so as you saw just a moment ago, I got the volume / balance pot soldered back in, the replacement loudness pot. Now I tested the loudness pot off camera on the analog meter, ran it through its range, and everything was absolutely perfect. So yeah, I was sent a good specimen, thankfully. So anyways, let me start with getting these relay contacts cleaned up, then I'll get the relay solder back in. Alright, so here's some of the relay contacts, just to give me an example. You can probably see how tarnished they are. I don't know if you can see the detail that I can see. I always say that because it's hard to tell from the back of the camera. But what I'm going to do is just apply a little dab of some Tarnex on these contacts here. Yeah, just a little dab, let it sit there for a few. And watch the tarnish just kind of melt away. You probably already see the difference there. Yeah, sure you can. They're getting pretty shiny. In fact, so shiny that the glare from the reflection is probably messing around with the camera exposure. I don't know. But anyways, So I'll just leave that on for about a minute, and then I will end up cleaning it off with some alcohol. You don't want to leave the Tarnex on. You've got to rinse it off. So, and I'm just going to use anhydrous alcohol to do that. Let me soak the other end of the swab, and I'll end up cleaning this off. Okay. May actually do a couple passes just to make sure that that Tarnex is off. Let me grab another swab real quick. But you get the point, nothing to it. It's just, depending on how badly tarnished it is, sometimes you got to leave the Tarnex on a little longer, you know, buff it out with a Q-tip with the Tarnex on a little bit, leave it on a little longer, let it eat through the tarnish. But in this case, you know, it was pretty tarnished, but not too horrendous. Just that little application obviously worked wonders. So, yeah, just... Okay, so yeah, that's looking good. You see that? Let me see if I can kind of move it around a little bit and what have you. And I'll polish these up a little bit more. I'm going to do the same thing with the contacts down in here. Okay, you can see those are really tarnished down in there. So what I'm going to do to get in there, because you know, there's more than one way to skin a cat, as I always say. I've got some little micro brushes that I can use to get in there, or I can just use a Q-tip and get my needle nose pliers, my little pliers here, okay, and just for example, just take it and just flatten out the head of this Q-tip, just really flatten it out so that I could fit it. Let me see. Yeah, so that I could fit it between these contacts. If I flatten out the Q-tip good enough, I could get it right in there and just kind of swirl it around a little bit with the Tarnex on it. And once I break up that tarnish, then I'll just repeat the process with a few other Q-tips and alcohol and just really get it rinsed out. And there you go, I'm good to go. That's about it. And you could do it a few different ways. You know, again, you know, not a big deal. Whatever works. So, yeah, let me go ahead and finish up all these contacts, and then I'll be right back for a final look. All right, so everything cleaned up real nice. You can probably see if I move this around at a few different angles, you might be able to see, you know, front and back, how clean those contacts are, even down in there. Maybe get a little light. Let's see. Might be kind of hard to see those ones down in there, but yeah, everything cleaned up real nice. So that's the objective. So let me get this relay back together. Alright, so she's all put back together, and post-service safe power-up went beautifully as expected. All I need to do is just a few more little odds and ends. I cleaned this up pretty good, the face and knobs and all that stuff, the glass, and yeah, everything's looking pretty good. As I said, with post-service safe power-up, that went good. I'm going to turn the camera over to the scope display, shut the overhead light off because unfortunately this LED shop light over my bench sometimes induces noise, artifact, and all that. In some units worse than others, but anyways, let me go ahead and get to it. And I have a signal piped into the aux in, and I'm going to be checking all the other inputs, but ultimately I just want to get this hooked up to some speakers, do a final audio test, and go from there. Alright, so here we are. We have both channels stacked on top of each other. Clean, undistorted waveforms there. I'm not going to go through all the controls other than the ones that were producing the most problems, just so I can show you guys that everything's looking good. So some of the noisy controls were the high and low filter switch. I think one of them was worse than the other. Let me just, you can probably hear me pressing them in and out. Everything is looking good. Okay. And then there was some noise in the tone controls, bass, mid-range, and treble. Starting with the bass. And no, I'm not going to run a square wave in it. All I'm doing is checking for noise, that's all. Everything is looking good there, mid-range. Yeah, that looks good. So let me get this back to center. All right, and treble, looking good. And now for the problem child, or what was the problem child control, the loudness control, which has a lot of range on it. This pot has a lot of range on it, as you can see. So let me go ahead and kick the volume down a bit. Here's our loudness control. All right, and that was causing all kinds of problems before. Looking good now. All right, great. So otherwise, let me go ahead and power test this real quick, and then I'll get on to piping in some music. All right, let me bring it up into clipping. Yeah, and even the clipping characteristics, the peaks and troughs are clipping symmetrically, so that's looking pretty nice. So let me go ahead and back it out of clipping just a hair there. All right. And that's giving us 59.45 watts into 8 ohms. This is a 50 watt per channel into 8 ohm receiver or amp. So yeah, doing good. It's overachieving its specified wattage, as you know these units often do. So everything's looking pretty good there. So let me go ahead and get some music into this thing and hook this up to some speakers and see what we got. Alright, so I'm not going to go over the procedure, but just for the record I wanted to mention that the bias is set, and you can see that it's hovering right about, well, 8 millivolts, close enough, okay, give or take. That's normal for it to move around as things are tracking a bit, but otherwise, yeah, everything is set. Factory calls for 8 millivolts plus or minus 2 millivolts. So we're looking pretty good, considering that little VR, little single turn VR is very, very difficult to set. You just breathe on it and you know it goes all over the place. So very touchy. So we're in the ballpark, we're looking good. So let me go ahead and move on. All right, so the unit is over here on an adjacent bench. I have music hooked up to it. I have the camera position here because it's centered between the speakers a little bit better. So I figured I'd just leave it here and give you guys a view to geek out on, because I know everybody loves test equipment. And otherwise, yeah, let me get started with the music. It is commercial music, so I can't play it too long. So I have a CD, some vinyl, and a cassette tape piped into the unit. So let me go ahead and get started. This has been a Spinning Head production.